Welcome to ROAV Perfect Classes. This is exercise 6.2 and in first question we have to find out EC in first point, AD in second point. We have given DE parallel BC. According to Thales theorem, we take here in triangle ABC, DE parallel BC is given. If DE parallel BC, then D intersect AB at and E intersect at AC. So it divides both sides equal AD over DB according to Thales theorem. AE over EC. AD is given 1.5 and DB is given 3, AE given 1, EC we have to find. By cross multiplying, we take here by cross multiply and we get result EC 1.5 EC is equal to 3 into 1 3 and EC is equal to 3 divide 1.5 and after dividing 3 by 1.5 we get 1.5 divided by 3 we get 2 centimeter. Now next point is next figure in triangle ABC, DE parallel BC, AD over DB, AE over EC according to Thales theorem. AD we have to find out and DB is given 7.2, AE given 1.8, EC given 5.4. After by cross multiply 5.4 AD is equal to 7.2 multiply 1.8, AD is equal to 7.2 multiply 1.8 over 5.4. 18 ones the 18, 18 threes the 54, 3 ones the 3 and divide by 7.2, 2.4. AD is equal to 2.4 centimeter is the answer. Now, next question is in this question we have given EFR points on the sides PQ and PR respectively of triangle PQR. This is the diagram PQR in which E and F 2 points on the sides PQ and PR is given and we have to prove EF parallel QR means it's the opposite of Thales theorem, or we can say that converse of basic proportionality theorem. Now given PE is 3.9 and EQ given 3 centimeter and PF is given 3.6, FR is given 2.4. We have to solve like this in triangle PQR. PE over EQ is equal to PF over FR. If both sides are equal, then we can say that EF parallel QR. 3.9 over 3 is equal to 3.6 over 2.4. After point deleting, we take here 0. Now cut with 3's table 3 13s 39, 3 10s 30, 3 12s 36, 3 8s 24. Again 3 4 3s 12, 4 2s 8. After by cross multiplication we get 26 equal to 30. This is not equal, so that's why we can say that EF is not parallel to QR. And in next question, next point, we have given PE4 in triangle PQR, PE over EQ is equal to PF over FR. PE is 4, EQ 4.5, PF 8, FR 9. Here we take 0 in after deleting point. 5 8s are 40, 5 9s are 45. Both sides are equal. So that's why we can say that EF parallel QR. It's proved. Now in next third point, we have given PE 0.18, PF 0.36 and PQ 1.28 centimeter and PR is 2.56 centimeter. First of all, we have to find out EQ and FR. For finding EQ, we write here EQ is equal to PQ minus PE. 1.28 minus 0.18. We get 1.10 centimeter. On the other side, FR is equal to PR minus PF. We get 2.56 minus 0.36, 2.20 centimeter FR. Now next step is in triangle PQR, we write PE over EQ is equal to PF over FR. PE 0.18, EQ 1.10 and PF is 0.36 over 2.20. By 2's table, we cut here 0.18 and we get here 1.10. Both sides are equal, so that's why we can say that EF parallel QR. In next question, in this figure we have given LM parallel CB, LN parallel CD, and we have to prove AM over AB, AN over AD. For proving this, we use BPT theorem, basic proportionality theorem. That means we use Thales theorem. In first figure, in this figure, in first side, in upper side, we take in triangle ABC. According to question, we have given LM parallel CB, and according to BPT theorem, we take here AM over AB is equal to AL over AC. This is your first question. And in lower figure, lower triangle ACD, we have given LN parallel CD. Now AN over AD equal to AL over AC. This is your second equation. From first and second equation we get both are same. These will be deducted, or we can say that cut, and remaining value we have AM over AB is equal to AN over AD, and it's proved. Now next question is, in this question we have given DE parallel AC, and this is full figure. That means first of all we have to solve this figure like this. In triangle ABC, DE parallel AC and BD over DA is equal to BE over EC according to basic proportionality theorem, first question. Now next part is figure, in which we have given DF parallel AE. It means we have take here this portion, and in this portion, in triangle BAE, DF parallel AE, and according to BPT theorem, BD over DA and BF over FE. This is your second equation. In both equation, first and second, when we take first and second equation, we see these are same, these are cut. We have get BE over EC equal to BF over FE, and in question we have to also prove this. So that's why here it's proved. Now next question is, in this question we have given DE parallel OQ. Now first of all we take this side. In triangle POQ we have given DE parallel OQ. According to BPT theorem, we take here PE over EQ is equal to PD over DO. Now right side we have given, in triangle POR DF parallel OR, and according to BPT theorem PF over FR is equal to PD over DO. This is your second equation, and from first and second equation we get PE over EQ is equal to PF over FR. If both sides are equal, then we can say that according to converse of BPT theorem, EF parallel QR. It's proved. Now next question. In this question we have given, we take left side of figure, triangle POQ. In this side AB parallel PQ. So we can say that OA over AP and OB over BQ according to basic proportionality theorem. This is first equation. And now second side of theorem. Now this is a, we can take here like this. And here we take second side. This is AC parallel PR. When we can say in triangle POR AC parallel PR, then according to BPT theorem it is OA over AP is equal to OC over CR. This is second equation. From first and second equation, from first and second equation we get OB over BQ is equal to OC over CR, and converse BPT. According to converse BPT, we can say that BC parallel QR. And in this question we have to also prove this. If AB parallel PQ and AC parallel PR, then we have to prove BC parallel QR. Now we prove it. And in next question, using basic proportionality theorem, using BPT theorem, we have to prove that a line drawn through the midpoint of one side of triangle parallel to another side bisects the third side. Means one point which is midpoint of one side, and from this point draw a line which is parallel to BC. We have to prove that it is intersect on another side, that is third side AC, it's bisect or not, we have to prove. So first of all we consider here figure. PQ is a line segment which is drawn through the midpoint of P of line AB, and PQ parallel BC we have given. According to basic proportionality theorem, we get AQ over QC is equal to AP over PB, and AP over PB is equal to 1 because both are the P is the midpoint of AB. That's why we can say that AP is equal to PB. So that's why we take here 1 by 1, and by cross multiply we get AQ is equal to QC. So Q is the midpoint of the AC. It's proved. And in the next theorem, using converse of basic proportionality theorem, we have to prove that line joining the midpoints of any two sides of a triangle that is parallel to third side. Means here we have to prove Thales theorem. And in previous question we proved according to converse of basic proportionality theorem. Now in this figure we can say that PQ is a line segment which is which joining the midpoints of P and Q of line A, B and AC. So here AP is equal to PB and AQ is equal to QC. Both sides both are the midpoints of AB and AC. So that's why they are both are equal to 1. AP over PB is equal to 1 over 1 and AQ over QC is equal to 1 over 1, And from first question and second question we get AP over PV, AQ over QC. And by using proportionality theorem we can say that PQ parallel BC. It's proved. In the next question, ABCD. ABCD is a trapezium in which AB parallel DC and its diagonals. Its diagonals BD and AC both are cut on the point O. And we have to prove AO over OB equal to OC over OD. So for proving it, first of all, draw a line, that is EF, through the point O such that EF parallel CD and in triangle ADC. Now take the first left side of triangle ADC. In this side EO parallel DC, and we take basic proportionality. According to basic proportionality theorem, AE over ED, AO over OC. This is your first equation. Now we take ABD this side. Here OE parallel AB, OE parallel AB. So here ED over AE is equal to OD over OB. According to first question and second question, we get AE over ED is equal to BO over OD. First question, from first question and second question, both are equal. So we get AO over OC equal to BO over OD. And on the other side, we can say that AO over BO, OC over OD. We can write by interchanging their places, and this will prove according to question. And next question is the diagonals of a quadrilateral. The diagonals of a quadrilateral ABCD. They are intersect each other at a point O. We have proved AO over OB like previous question, OC over OD. We have given in previous question we proved it, but now we have given these points and we have to prove that this is a trapezium or not. Now first of all we take we draw a line OE for proving it, OE, and in ABD OE parallel AB, AE over ED is equal to OB over OD, first question. And like this we take on the other side EO parallel DC and AO over OC, OB over OD. This is your second equation, this is the first equation. And in both equation we get AE over ED is equal to AO over OC. And so we can say that EO parallel DC by converse of basic proportionality theorem. So that's why we can say that AB parallel OE, OE parallel DC, and AB parallel CD. So that's why ABCD is a trapezium. Thank you. If you like my video, please like and share my channel for next coming videos.